The second type of oligopoly is a Cournot, and the characteristics are slightly different. First, there are a few firms in the market. That's an oligopoly. Next, the firms produce either a differentiated or a homogeneous product. Third, the firm behaves as if the rivals will hold their output constant if it changes its output. And finally, barriers to entry do exist. We're going to start with a duopoly. Each firm makes an output decision under the belief that its rivals will hold its output constant. However, each firm then makes different moves based on what they see. The best way to analyze this type of relationship is to use a new tool called a best response or a reaction function. In other words, we make a move, we watch for reaction, we make another move. So it's more of a dynamic system that shows the movement of the adjustments made by the firms in the oligopoly, in this case, a Cournot oligopoly. There are some mathematical functions that we'll look at later on. We'll do an example of this. These were just used as given, and we won't derive them. But we have a linear demand curve, and there's it downward sloping because we're not in a perfect competition setting. And then we'll have cost functions, and then the reaction function. So these last two are new to us. It shows the Q1 move given the reaction function based on what Q2 does, right? So that's why it's reaction. It is the interaction between firms 1 and 2. And Q2 is from the standpoint of the other firm. Q2's movement is based on the actions of firm 1. All right, let's set the stage for Cournot. First, notice that the axes are different. On the horizontal axis, we have quantity 1 based on the production of firm 1. On the vertical axis, we have quantity 2 based on the actions of firm 2. If there's a monopoly for firm 2, they're going to produce here. And the reason is there's zero quantity for firm 1, and firm 2 grabs all the quantity here. All the points along this line represents the points where there's a reaction of firm 2 based on the quantity produced by firm 1. So that's why this curve goes down here. Eventually, at this point, where if firm 1 to produce this quantity, firm 2 is not going to play. Their volume actually goes to 0. That's why we call this a reaction function. We have the same condition for firm 1, where if they get all the volume, because there's 0 in Q2, then they will operate here at a monopoly intercept, and all the points along this line represents what firm would do given different quantities of production by firm 2. So let's start the dance. The dance just starts anywhere, doesn't matter because the equilibrium will be reached. So firm 1 will see 0 from Q2 and produces at their monopoly price. So that represents this quantity, but the story just begins there. Firm 2 sees this quantity, and at this quantity on the blue line, on the firm 2 reaction function, they're going to want to be at A. So they're going to go move and produce A. Next step is now firm 1 sees A, and that translates to a different point for their function, and they're at point B. So they're going to drop production if they see this response from firm 2. Now the next step is firm 2 sees the reaction from firm 1 reaching point B, and this point, which is B, at this quantity of firm 1 production, firm 2 is going to be one at C. So they're going to move production up to the point represented by C. And the next step is then firm 1 will respond by yet another reduction in their quantity because C is now moving in with more quantity, move to D. Eventually, we'll get to a Cournot equilibrium, which is at the intersection of the two lines, the two reaction functions for firms 1 and firm 2. And that is this point, right? So the intersection of the reaction function for firm 1 and the reaction function for firm 2 is the Cournot equilibrium, and that's where it would sit. So in a Cournot equilibrium, the situation is resulting because neither firm has incentive to change its output given the other firm's output. They both made their adjustments to triangulate, if you will, onto the point of equilibrium.